Alright, welcome back everyone. This is the fourth video in my video tutorial series on Eagle CAD. Today we're going to start a new project, something more useful than the previous one on the LED blinking. What we're going to do is build this thing called the AVRISP. It's actually based on a sketch from the Arduino IDE called the ArduinoISP sketch. Actually, I'll show you that real quick. Let me see if I can open it here. If you open up the Arduino IDE and you go into the examples, you'll see a sketch called ArduinoISP. And this sketch here allows you to program AVRs directly rather than using the serial port. Some of you may know this already. You can't when you buy a chip directly from, say, DigiKey or eBay or straight from Atmel, the chips don't come pre-programmed in order for you to upload over USB. You have to use this thing called a bootloader, and this sketch here will allow you to do that. But to run the sketch, you have to have another Arduino, or you have to have a programmer. So that's what they're doing here in this image. They're using a circuit, and you can use another Arduino to program an Arduino. This one doesn't have the chip inside, or it's kind of complicated. So what we're going to do is we're actually going to make a little circuit board with just the Arduino chip on board, just for programming Arduinos and AVRs in general. It doesn't have to just be an Arduino. But we're going to take the similar circuit and use the same sketch that's in the program. So we'll start from the beginning and work our way to the end. We'll possibly even purchase the PCBs and upload the code and everything. Alright, so let's start. The first thing we do is open Eagle. So let's go ahead and open our Eagle CAD program. And I think it's open right now somewhere. Is it? Yeah, there it is. Okay, so we need to create a new project, right? We have these two projects from the previous videos. So I'm going to right click on the tutorials folder which we created before, and I'm going to say new project. And what we're going to call this is Arduino ISP. You can call this whatever you want, but I'm going to call it Arduino ISP board. How about that? I always like putting board at the end of my projects for some reason. Alright, so now that's done, we're going to right click on that and go new schematic. There we go. So now we got a schematic. I'm going to go ahead and save this before we do anything else. So file, save as, and notice how it puts it in our Eagle folder, tutorials, which is our tutorials folder, and then our Arduino ISP folder. So if you go up one, you'll see our previous projects. Here's our test project from video 1, then basic schematics stuff. So let's go into here, and I'm going to name this Arduino ISP board. Yeah, just Arduino ISP board. Okay. Now, alright, so we need some parts. We need to add some parts into Eagle in order to do this correctly. So what I'm going to do is go up to the add button, and the first thing we need is this thing called a or the USB connector. So let's see if we can find one of those. See, is it this one? No. I have the USB mini, which I believe is this one, but it has these two little holding holes right there. So let me see if I can find. Yeah, I think this is it. This is it right here. Okay. Actually, what's this right here? Let's look this up. Yep, that looks like it. Okay. So we're going to go ahead and use this one here. Actually, you know, let me show you something else. This is a better way of doing this. I already have this. I purchased one of these USB connectors from sparkfun, and they already have it in this library here. So if you go to this website, GitHub, the easiest way to find it actually is go to Google and type sparkfun Eagle library. It's the first link right here, and it's going to bring you to this page here. And you're going to press download zip, which is a zip file with all of these Eagle libraries. And I'm going to show you how to import these into Eagle. Alright, so here's our downloaded folder. It's a compressed folder, obviously. Open it. See all the folders in here associated with the Eagle file. or the Eagle libraries. And we're going to open up a new window, a new Explorer window. And we're going to navigate to the C drive, Program Files x86. It should be under Eagle Library. And then we're going to copy this folder here. Just Control C and then Control V and copy it into here. It's going to ask you if it's okay to do it, and just press OK. It's fine. There we go. Alright, so you can close those two. We're going to go back to Eagle, and we're going to go into the schematic window that we were at earlier, and go up to the Library tab here and press Use. Alright, now we got to find... Oh, sorry, I'm not in the right... I put it in the wrong location. Oops. Okay. Open this folder again. And then the other window. And apparently it's at the root directory here. Yeah, there it is. Eagle 7. I put it in the wrong location. Sorry about that. So just make sure you put it in this spot here. Computer, local C drive, Eagle 7.1.0. If you're on Eagle 7.1.0, you may be on a previous one. But I'll leave it up to you to figure out where this folder is for Eagle. So copy this and then paste it into here. And is it at the bottom? No, it's at the top. There it is. Okay. Now we can close these two windows. Go back to Eagle, Library, Use, and there it is right there. Now what I'm going to do is I'm going to select all of them. Every single one here. From now on, actually, Eagle will automatically load these, so you won't need to do this again. That's why you put it in that library location. Otherwise, you would have to go Library, Use, or change the location for libraries to be loaded. Alright, so now that Eagle has loaded the sparkfun libraries that we just downloaded, we're going to go to Add. And we're going to find the sparkfun library. There it is. And it should be under connectors right here. Is there anything about USB in here? There should be. Here it is. USB mini 5-pin. Alright, this is it. I know it is. It definitely looks like it. Is this it? No, that's not it. That's definitely not it. Okay, so this one. USB-mini B-5-pin. This is the connector that I particularly have. So we're going to press OK, and we're going to place this right here. Then we're going to hit Escape again, and we're going to find some more parts. Now what we need is a FT232RL chip. This is a USB to serial IC. And sit right here. And I'm going to go with this one, the basic SOP, because we don't need all these extra pins here. This is all we need here. It's just the DTR pin, power, of course, all this stuff here. So, luckily we added this sparkfun library. Otherwise, we would have had this use this more complicated looking one. But we're going to use this one right here, the sparkfun digital IC library. And inside that, there's a component called FT232RL-basic SOP. So we're going to press OK. And we're going to drop that in here. And now what we need is the ATmega 328P. Search for that. Oh, that's not in here, is there? Is this it? Here it is. Okay. Again, it's in the sparkfun library. I'm surprised. Alright, so we're going to add this here. This is the thin quad flat pack version of the Arduino. We're going to use this. I like using surface mount over dip. We could have used the dip version, but I personally don't like. I like the SMD. It looks a lot better. It's a lot smaller. It's a lot cleaner. Keeps the price down in PCBs for sure. Alright, so now that we have that, we're going to press OK. And drop this in here as well. And now what we need is a crystal for the Arduino. So I'm going to type xtal. And the one I have is surface mount, so I'm not sure if that's in here. We might have to make that library. Actually, you know, I think that would be a good video. I'm going to cover that next, how to make a library. Alright. Let's see if we can find some connectors then. Can't seem to find the right one. Okay, we need one of these, I know. I don't want the surface mount one though. And I don't really like the locking one, but I'm looking for the shrouded one. You don't have to put the shrouded one, but I'm going to put the shrouded one. This is the 10-pin version. We're also going to need the 6-pin one. I know we're going to need one of these for this Arduino here. And am I going to have to make a shrouded one too? Apparently. Okay. Alright, so let's start, actually we need a couple more parts. Let's add a few more things. First thing I need is to go to supply library. We need to find the power, here's supply, okay. So we need ground. Drop that in there. Escape. And if you guys are getting lost in this video, go back and check out the previous videos. I don't want to waste too much time on things that we covered previously. So yeah, if you're having issues with, you know, how I'm flipping this right now, go ahead and watch the first couple of videos because we covered all that back then. Okay, so what I'm going to do is I'm going to flip this USB connector here. And then I'm going to move it again because it doesn't line up right with this device here. Alright, so I'm going to move this to the right position like that. Move the ground right there. Power's right there. Zoom in a bit and start connecting these up. So that's the wire net. So we're going to go boom to there. From here to there. D minus to USB D minus. USB D plus to USB D plus. And then I'm also, actually, you know what, I'm going to drag this down a bit. And I'm going to connect these. I like connecting the shield of the USB connector to ground. Because that's what these pins are out here are doing. They're the shield. There we go. See how that pin didn't at first give you a dot? Just by me moving it and then re-putting it there made that little dot come show up. Alright, so this USB connector is connected. Now we need to connect the VCC pins of it. So I'm going to run a couple pins over to here. We need to connect it to VCC IO as well because this pin tells this chip what voltage level the output needs to be. So you could actually put a little switch right here between 3V3 out and VCC, or the USB 5 volts, and switch between 3.3 and 5 volt for this, which is a good thing if you're just using this as like an FTDI adapter and you're not sure what's going to be plugged in on this side. But we know exactly what's going to be plugged into that. It's this thing here. It's this that might be plugged into something different, but I'm not going to do that in this video. We might put a switch just to flip between 3.3 and 5 volts. But for now we're just going to connect this straight up to this guy here. Alright, next what we need to do is find the serial pins. Where are those? Are those over here somewhere? Yeah, TX and RX. Okay. So what I'm going to do is I'm just going to draw a couple little wires coming off here. That's it. Just a couple. And then this one too. And I'm going to come over to this tool right here that says label. I'm going to select that and select each one of these. I'm going to select this and then drop it right on the wire. See how that little wire connects it? This tells you what the name of this node is, this wire basically. And see how it says N $4, N $5? That's Eagle naming these nodes on its own. So now we're gonna name it. We're gonna tell Eagle exactly what this node is and what we want to name it basically. So I'm gonna come over here to the name tool, right? That's name. And I'm gonna click on the node we want to name, and I'm gonna call this RxD. Now I know you guys are thinking, hey, why are you connecting RxD to TXD? But that's the way this happens. So on this side, I'm going to connect this to RxD. Receive is connected to transmit, and transmit is connected to receive. They're flipped. So I always like to flip them on this side. It's a little bit standard, otherwise you get confused as to which side is flipped. But I like to make sure that the master, or the chip that the bigger chip in the picture, not the FT232 chip is always the same pins here. So I always flip it over here. So TXD. Oh yeah, and then here I'm gonna call this DTR because we gotta put a little bit more circuitry over here for that one. And then same thing on this side for this pin here. Label. I'm going to name this as well. So remember, we already flipped it, so we can just call this RxD. Okay, so here it's saying warning, connect N $3 and NXD. So we haven't seen this before yet because there hasn't been two different nodes that we're connecting. So it's asking us if we want to connect this with the other pin that's over here already connected. So we're going to say yes. So now, even though these aren't physically connected, even though we name them, so they are the same pin. So like if I go to show here and I click this, see how they both highlight? It makes the schematic look much neater. So I definitely recommend you guys use that tool instead of literally drawing wires everywhere. I hate it when it looks so disorganized, in my opinion. And then same thing here. I think you can turn that off. I just haven't figured out how to yet. So it gets annoying after a while. This bing, bing. Alright, so I'm going to move the Arduino chip over a little bit. Just move it like, but like that. That looks pretty good. Alright, and you know what we need? We need some resistors and capacitors. So I'm going to go to add, search for a resistor. Here's RUS, and I'm going to use an 0805, or no, sorry, 0603. So that's it right there. I like the ANSI symbol like that, so I'm going to go ahead and go RUS. Drop that there. Escape. Now we got to find a capacitor. CUS 0603. Perfect. Drop that right there. Alright, so now when we are programming this device, when we are sending something to this device over USB, this pin acts as a reset. It resets this device, and to do that, it has to have this capacitor and this resistor in a certain configuration to create this time constant. I can't remember the electronics behind it specifically, but I know it's meant to hold this in reset for a certain period of time. So the value of this capacitor needs to be 100 nanofarad, or somewhere close to it at least, and the resistor is a 1K. Alright, so I'm going to move this capacitor. This is a series capacitor. And then the resistor goes up to power to 5 volts. I'll move it over like this. And then I'm going to copy, where's my copy tool? There it is. Copy my 5-volt thing, drop it on top of my resistor. Alright, one more label. And this one I'm going to call reset. And we're going to connect that straight to here. Like that. Another label. Yeah, so definitely use labels. Labels look a lot better. Move this again. And we need another 5-volt thing up here for the power pins. We're not going to be using the analog reference of this device, so I'll just leave that blank. And then ground, let's copy ground over. Then we needed to connect this here. Oh, we need more 5-volt jumpers. And another ground. More labels. Name tool. It's going to be MISO. This is S clock or serial clock. This is going to be reset. And this is going to be MOSI, or master out slave in. This is master in slave out, by the way. And that's going to connect to these pins right here. Just like it looks. So simple, right? I know. Makes too much sense. More labels. Name tool. MOSI. MISO. This one's just like it's named here. MOSI to MOSI, MISO to MISO. And then S clock, serial clock. And now these pins here are connected to this right here. And same thing with the reset. So all we need is the crystal. We need to hook up the other shrouded 3-pin version of this. So there's, let me show you a picture of what it looks like. AVRISP. Okay, so there's 2 different versions of the AVRISP connector. As you can see, there's a 6-pin version and there's a 10-pin version. Sorry, I'm not sure why this 10-pin version has so many grounds. But we're going to put both of them on the board so that the user can connect either or. It's a little neater, looks better, but you would probably be using this 6-pin most often. And I like the shrouded ones for this design. If you go into the info here, yeah, see how this is shrouded? It'll look much better. Won't slip as much. Alright, so we've been in this video for about 25 minutes. I'm going to cut it off here. The next video we're going to cover how to make a library for the crystal, and then the library for the shrouded the 6-pin connector. And then we'll finish off the schematic video after that, and then make the PCB. And then possibly, or we will eventually go into making the Gerber files and ordering them online, have your board manufactured. Alright, so before we close, we're going to go ahead and press File, Save. Go ahead and save our project here. And then we can close it. So yeah, thanks for watching, everyone. Go ahead and let me know if you want to see anything else, or if you have any questions. And like and subscribe. It's very much appreciated. Alright, see you next time.